In this series of videos, we're going to talk about patterns. There's a few different types of patterns we'll be discussing, but we will talk about strategies that you can use to figure out what the patterns are for each. Our learning targets for these videos are: I can identify and describe the relationship found in patterns. I can solve practical problems involving identifying, describing, and extending input and output tables. And I can identify the rule in a numerical pattern found in a list or table. The first one we're going to focus on, though, is just identifying and describing the relationship found in patterns. And we're going to look at that in terms of numbers in a series. These are simple patterns that you've probably worked with before. And so we're just going to walk through an easy example. So if you have a list of numbers, 4, 12, 36, 108, 324, the first thing you need to decide is, what is this rule for the pattern? What is the rule for this set of numbers? How would I figure out what the next number is? So first, let's think about this. I see 4 and then I see 12. Well, what do I do to 4 to get 12? I think I can add 8. So we're going to start with the possibility of plus 8. So I test it. 4 plus 8 is 12. But then I look at my next set of numbers and I have 12 and then 36. 12 plus 8 does not equal 36. So I know right away that plus 8 is not the rule. So let's look at another possibility. What else can I do to 4 to get 12? Well, I know I can multiply by 3. So 4 times 3 is 12. Well, what's 12 times 3? 12 times 3 is 36. 36 times 3, and luckily you'll be using a calculator, but 36 times 3 on your calculator you'll find is 108. 108 times 3 on your calculator is 324. So it looks like the rule for this pattern is times 3. So that just means that you take the number, multiply by 3 to get the next number. So we found out the rule, which is multiply by 3, and that's usually only the first step in solving problems like these. Usually you'll see another question, a follow-up question, such as, what is the 8th term in the sequence? Now, a big mistake some people make is they automatically assume that, oh, the rule is times 3 and I need to know the next term. So I'm going to take 324 and multiply that by 3. However, the question is asking for the 8th term in the sequence. So first you have to figure out how many terms you already have. And I see 4, 12, 36, 108, 324. That's 1, 2, 3, 4, 5. So those are 5 terms. So I actually need to figure out first what the 6th term is. So I figured out that the 6th term is 972 because I take 324, multiply by 3, and I get 972. Let's figure out what the next term is. By multiplying by 3, 972 times 3, I get 2,916. The next term is 8,748, and that's the 8th term because 2,916 times 3 is 8,748. So the 8th term, to answer this question, the 8th term is the sequence. In the sequence is 8,748. And like I said, you'll be able to use a calculator for this, so there's not going to be too much rigorous math that you need to do. So this is a simple problem of just looking at numbers in a series, figuring out what the rule is to get from one number to the next, and then answering what the 8th term is in the sequence, or the 9th term, or even the 12th term they could ask you. Really, you just have to make sure that you know which term you're being asked to find, because if you were being asked to find the 6th term, then the answer would have been 972. But the question asked for the 8th one, so we had to think 1, 2, 3, 4, 5, 6, 7, 8. I need the 8th one, and that was 8,748. When you're working with patterns this year, you'll be looking at rules that can include adding and subtracting whole numbers, decimals, or fractions. So the example we just did was just whole numbers and just adding or subtracting or multiplying and dividing whole numbers. But just so you know, you could also need to add or subtract decimals or fractions to figure out the terms or the next term in the sequence. So stay tuned for the next video to talk about input and output tables. The next type of pattern problems we're going to be talking about are input and output tables. So this is what an input-output table looks like. Sometimes you'll see the headers labeled in and out or X and Y, but these are basically pattern tables where you have to think about, what do I do to the number in the first column in order to get the number in the second column? So the way these work is that the rows actually have nothing to do with each other. You look at each row as its own individual entity, I would say. So this 2 has nothing to do with the 5. The 5 has nothing to do with the 10. Instead, we have to think about, what did I do to 2 to get 6? What do I do to 5 to get 9? So let's think about what a possible rule could be. The possibility is multiply by 3, because 2 times 3 is 6. Let's see if that works for other numbers in the table. Well, 5 times 3 does not equal 9. So right away I can say multiply by 3 is not the rule. Let's try another one. What else can I do to 2 to get 6? I know that I can add 4. So 2 plus 6 is 4. 2 plus 4 is 6. 5 plus 4 is 9. 10 plus 4 is 14. 12 plus 4 is 16. And 15 plus 4 is 19. Every single number in the table worked out with this rule of plus 4. So that means that plus 4 is the rule for this table. Now, that was a very simple input and output table. Sometimes, like I said, you'll see them labeled X and Y. And really the only difference here is that when you're saying the rule, you basically replace an X, or place the X first. So if I'm looking at this table, I see 4. What do I do to 4 to get 1? Maybe I subtract 3, but that doesn't work for the next one. But what else could I do to 4 to get 1? I know I can divide by 4. 8 divided by 4 is 2. 20 divided by 4 is 5. So the rule divided by 4 is what works here. However, I wrote it as a variable expression where I put X first and I said X divided by 4. That just means you take whatever numbers in this column and you divide by 4. It's the same as just saying divided by 4 is the rule. It's just another way to write it when you're working with variables. Now with this problem, you have to fill in also the question marks. Well, now that I know that divided by 4 is the rule, I'm going to fill in the question marks by taking 12 divided by 4 to get 3. So I'm going to fill in that question mark as a 3. I also know that 32 divided by 4 is 8. So I'm going to replace that question mark with an 8. And that's really how input, output, or in and out, or X and Y tables really work. Sometimes they're called function tables as well. Now, you should be careful because sometimes you know what the rule is. And in this case, this rule for this table is -5. I know my input is 5, my output is 0. So 5 minus 5 is 0. 7 minus 5 is 2. So that rule does work for this table. I need to replace and figure out what the question marks are going to be. So I'm going to take 13, and I'm going to take my rule -5, and 13 minus 5 is 8. So I'm going to replace that question mark with an 8. However, in the last row, I already have the output number, and I need to figure out what the input number is. So if you're thinking -5 is the rule, you might want to do 27 minus 5 and get 22. But that's actually not correct because the output number is 27. So you have to think about, what did I do to the input, or what number can I subtract 5 from to get 27? So if the input number is the number I don't know, whatever number minus 5 will have to equal 27. So to figure that out, all I have to do is do the reverse or the inverse operation and do 27 plus 5, and I get 32. So I know that 32 is the input number for this problem. The last type of pattern problems we're going to talk about are patterns as they relate to word problems. So let's look at a word problem together. Mrs. Saul is creating video lessons. While each of these video lessons is only 5 minutes long, there is some preparation work that goes into it. So it does take longer than 5 minutes to create each one. So Mrs. Saul is creating video lessons. It takes her 30 minutes to create 2 lessons, 60 minutes to create 4 lessons, 90 minutes to create 6 lessons, and so on. How long will it take her to create 9 lessons? So there's a few different ways that you can solve this problem, but I like to look at this one as kind of an input-output problem. So I'm actually going to create a table, and my input column is going to be the number of lessons, and my output column is going to be the time it takes to create them. So 2 lessons takes 30 minutes, 4 lessons takes 60 minutes, 6 lessons takes 90 minutes. And you might be thinking, well, I can do 8 lessons is 120 minutes. But the problem is we're not trying to figure out how many minutes 8 lessons will take. We're trying to figure out how many minutes 9 lessons will take. So just by looking at this, it looks like I can do, let's see, from 2 to get 30, I can multiply by 15. So I'm going to try the rule as times 15. Because 2 times 15 is 30. Let's see if it works for 4 as well. 4 times 15 is 60, and 6 times 15 is 90. So it looks like this rule as times 15 is actually working out for this problem. So the next number we can even jump up to 9. We don't have to do 8 like we would probably want to do 8 times 15 to get 120, but we don't need to now that we know that times 15 is the rule. So if I take 9 and multiply that by 15, I get 135. So the rule for this problem, or the answer to this problem, is 135 minutes, or if you want to convert that into hours and minutes, that would be 2 hours and 15 minutes. This is the type of problem where there are a few different ways to solve it, but sometimes it's easier to organize it in a table the way that I did and to figure out the rule for that table, and that will help you solve lots of word problems like this, where they start to get a little bit complicated, a little bit wordy. But if you just take your time and organize the information into a table, you'll find that it's probably very similar to an input-output table, and you can solve several word problems like this. So thanks for watching. I hope these videos were helpful to you.